Welcome back. So as we use groundwater, in most places around the U.S., the attempt is to use the water but then recharge it, whether it's from treated wastewater, excuse me, or diverting water from elsewhere. Diverting water from elsewhere, we'll talk about here in a little bit later. But what if we just start using too much, where we're pulling more water than we're putting back in, whether it's from wastewater, surface water, whatever. So what happens if we're just pulling too much? Well, let's say you have a pumping well. As you start to pump out groundwater, it doesn't just all everywhere go down equally. Again, it follows the contours of the land. It moves. Groundwater moves very slowly. It does move, but it moves very slowly. It's making its way through all those individual little pieces of dirt, rocks, and whatever. So it does move very slowly. It does flow a little bit from high to low. But if you're kind of pumping out a bunch of water, what you can do is create in the water table something called a depression or a cone of depression, where you're kind of pulling out groundwater and it's kind of causing it to dip in a lot of different places. If you just end up pulling up too much groundwater, well, then the water table everywhere will begin to lower. Now again, water is in between. Groundwater is the water in between the individual pieces of sediment and dirt and soil and rocks. Well, that's actually helping to give some support, some structure to the land surface above. If you have a table and you start to take legs away from the table, eventually that table is going to fall. Well, similar idea here. If you start to take away some of that water that helps to fill in that gap, to help support the land above, you start to take away that water, well, some of that support is now gone. So the land is actually going to subside, sink down. Typically, a subsidence process is very, very slow, but it does occur, and it can occur over a large area and create a subsidence area that falls very far. For example, this is the San Joaquin Valley in California. A lot of agriculture, a lot of farming. So they're pumping out a lot of groundwater. Well, this area is also kind of dry. It just has a good climate to grow certain things. So they're not getting a lot of water to recharge the aquifers. So they're just taking water. Well, the ground began to subside. So starting from 1925 down until 1977, so that's 52 years. So in 52 years, the ground subsided that far. I don't know if you can see it here, but it says 9 meters. So if you use this guy as a reference, here's a little bit close-up view. If we use this guy as a reference, 1, 2, 3, 4, 5, about five of him high. So if let's say he's 6 feet, so that's about 30-ish feet. So yeah, 9 meters is about 29.5 feet. The valley subsided, just sank almost 30 feet in 50-some years. That's just under a foot a year. That's a lot. That's a lot of water they're pulling out. Again, you pull that water out, you're taking out that support, subsidence can occur. Again, it's a gradual process. Sometimes it can be a sudden sinking of the Earth's surface. We'll talk a little bit later about something called sinkholes associated with groundwater, but this is a little bit different. This is kind of the whole ground just sinking because of the support. You get subsurface movement or taking away that water, the support isn't there, it's going to subside. Subsidence is a global problem in the United States, more than 17,000 square miles in 45 states, an area roughly the size of New Hampshire and Vermont combined across the U.S. Now, those aren't big states, so you might say, oh, that's not a lot, but still, these are populated areas that are sinking. 80% of subsidence issues are caused by groundwater depletion and then compacting the ground above it. You're taking out that water that's in between those pore spaces. All the ground above is going to compact and essentially sink down. Again, you might be like, well, no big deal. Well, yeah, big deal. If you have houses, structures, buildings, if the ground is moving and shifting, you're going to break those foundations. Buildings are going to be destroyed. Houses are going to be destroyed. Power lines are going to fall. Sewer lines below ground are going to snap. It's a big, big deal. And again, it's a global problem. As the population of Earth continues to grow exponentially, it's only going to get worse. All things water are only going to get worse. So around Arizona, where is subsidence occurring? So Phoenix is right here. This is Central Phoenix. This is the 101. This is the 10. So Phoenix area is right here. Avondale's like right here. So just north of us is an active subsidence area. And from the 1940s until now, so about 80 years, this area has subsided about 20 feet. About 20 feet. Historically, there were a lot of farms in this area. And that's where most of these that you see, for instance, in between Phoenix and Tucson is down here, a lot of farming in these areas. East of Tucson, a lot of farming in these areas, hence subsidence. So yeah, it does occur across Arizona, mostly central and southern Arizona. Here's a subsidence example in Wilcox, which is east of Tucson. So Tucson is here. You take the 10. Wilcox is over in this area where this yellowish thing is. In this particular area, from 1969 to 2018, in this case, 9.7 feet, the ground has subsided. Any compaction of ground and subsidence of ground is a big deal. Again, power lines, water lines, a number of different things, roads, all of these things can be affected. All right. So, farming in the desert, is that the smartest thing? To the farmers, yeah, that makes sense because that's their livelihood. But overall, if farms are using so much of the desert's water that it's going to harm the ground and deplete the water for the rest of us, is it worth it? That's the kind of things we need to talk about. So again, this location is north of Wilcox, and you can see all of these circles are little farms. Probably growing, it looks like corn back here. Corn. The reason they're all circles like that is because at the center you'll have a sprinkler, and it kind of rotates around that whole area. The whole sprinkler system moves around, so hence you get this circle. So yeah, so those are all farms. Look around. Barren desert, no vegetation. Is this the best place to farm? The climate is good for farming, but is it good? Is it sustainable? Probably not. Let me give you another part of the super secret code is the number 9. You got me? The number 9. One more time, the number 9. So that's some issues with groundwater. It's a necessity, but if we use it too much, we can cause the ground to sink over time. Another topic we want to talk about when it comes to groundwater are caves, caverns, and sinkholes. Ooh, fun stuff. We'll talk about that in the next video. See you in a minute.